Welcome to part 3 of section 2.1. We have one more problem to work with function notation. We are given this function, f of x is equal to the absolute value of x plus 3 over x plus 3. Now remember, with an absolute value, you calculate whatever is inside. It works like a grouping symbol when it comes to order of operations. And then once you have it simplified inside, then the absolute value says whatever is inside, you make it positive. If it's already positive, it stays positive. If it's negative, you make it positive. Okay, so let's find f of 5. So we're going to take 5 and plug it in for x. So I have the absolute value of 5 plus 3 over 5 plus 3. As a suggestion, exaggerate the height of your absolute values. If you're not careful, you'll pick it up as a 1. So make sure it's significantly larger than your other numbers. So what I have here is the absolute value of 8 divided by 8. The absolute value of 8, that's a positive number, so it stays positive. I have 8 divided by 8, which is 1. Now let's plug in negative 5. All right, so this is the absolute value of negative 5 plus 3 over negative 5 plus 3. Well, negative 5 plus 3 is negative 2. So I have the absolute value of negative 2 over negative 2. The absolute value of negative 2 is positive 2. So I have 2 divided by negative 2, which is negative 1. Okay, now before we go on to this one, there's a pattern here. There's something important that we're expected to recognize before we go on to this one. Look what happened right here. If when you did the calculations, when you did your calculations, if you got a positive number with the addition, then you're going to get a 1 because you're always going to have the same value inside the absolute value as here. And if when you add these together, you got a positive number, then your signs are going to stay the same and you're going to get positive 1. Whereas if when you do the calculation, you got a negative number, then your signs are going to end up being different and you get negative 1. So no matter what number we plug in here, we are either going to get 1 or negative 1. Okay, so keeping that in mind, I want to plug negative 9 minus x into my function. Okay, so I have the absolute value of negative 9 minus x plus 3 over negative 9 minus x plus 3. So this simplifies to the absolute value of negative 6 minus x over negative 6 minus x. Okay, so we know we are either going to get 1 or negative 1 with this. And we need to actually simplify a little bit further and split up our two cases. All right, so this is going to equal either, and we write it like this when you have two choices. This is equal to either 1 or negative 1. And we have to put some conditions on this. So it equals 1 if, and I'm going to write something here, and it will equal negative 1 if something else. Now, what did we say here? It's going to equal 1 if once you add, you get a positive number. And it's going to equal negative 1 if once you add, you get a negative number. Okay? So if I want to know when I get 1, then I'm actually asking, when is this number, negative 6 minus x, when is this greater than 0? Because if it's positive, we get 1. So let's just figure out where this thing is positive. All right? And we want x by itself, so let's just move this over to here. So this is negative 6 is greater than x. Or so this is the same thing as x is less than negative 6. Okay, so this is our condition right here. It equals 1, it's going to be positive if x is less than negative 6. It is equal to negative 1, and it's just going to be the reverse of this, if x is greater than negative 6. Notice we don't have an equal to on here. And the reason for that is if it equals negative 6, then we get 0 in the denominator, and that's not allowed. Okay, that's the end of 2.1.